This is Max Proud and welcome to the quick introduction tutorial for Hayate 3. What you see here is the content of the asset bundle you get after purchasing on the asset store. It contains all the Hayate classes, the editor script, some image effects for the demo, and of course the demo itself. Additionally, you can find a manual in the main asset folder. Now let's get right into it. Create a new particle system, reset it, and set it to world for easy use in 3D space, and add Hayate. And that's it. Now you can start editing all your turbulence and effect options. Let's start with Pearl in noise. But before that, let me just quickly add a new material to the emitter to make it easier to see. We got some materials here in the demo folder. I'll just add the glow sphere, set the emitter to a much smaller value, let's say 0.1, start speed to 0 to have only the turbulence affect the position of the particle, and yeah, we're good to go. Maybe I just adjust the size a little bit. Okay, here we go. Now, as you can see, if you move the emitter around, these particles will not follow the emitter. You can change that here in the simulation space in Shuriken. If you set it to local, it will behave as expected. Just moving it around, rotating it and stuff. It's pretty basic stuff here, but let's start with the Hayate turbulence settings. I'll cover these things later in a different tutorial so you can see what effects you can create with Shuriken and Hayate together. So now we set all three axes to Perlin turbulence noise and the simulation to velocity relative. If you want different kinds of effects, you can change the simulation space to position or relative or absolute. That means when you have relative simulation and assign it to velocity, that means that it will be added up. If you set it to absolute, then the turbulence will be equal to the velocity. Let's start with that to see what it does. Well, at first it's very slow because there's no accumulation of velocity, so we have to use much higher values here in the amplitude setting. The amplitude basically affects the speed of the particle. This is only used for the absolute and relative values as well as position. You can also use the Shuriken speed value, but if you set it to absolute, it will always be overwritten, so you should keep that in mind if you want to add some speed here. See, it doesn't do anything. The frequency is the size of the turbulence field. I think the best way is to use the debugging menu to see what it actually does. Okay, this is the debugging options. I'll come back to this later. I just want to show you how this looks. So let's mess around with this a little bit. Let's set it to 2, and you see it's much bigger. The waves here, the frequency of the waves here is much longer, so that means that particles will always fly on a more straight path and only take very wide curves. If we reduce this to, let's say, 0.5, and make this a bit shorter, you can see these particles are changing directions much more frequently. That's because the turbulence field is much more dense. If you don't want delta time simulation for this effect, you can always lock the FPS, and then, as you can see here, the movement, the delta speed is not being calculated. It's just being set to a fixed value, and this is very handy because it's actually a real simulation and time matters and not frames. Okay, now let's change the amount of the particles a little bit to make this effect much more visible here. Let's say 1000 particles per second, and deactivate debugging so you can actually see the turbulence field in action. Okay, let's change this again to see what it does. As you can see, these curves here are much wider, and this is yeah, very important for a different kind of style. Let's say you have a snowstorm, then you want particles to fly very long curves and have them be realistically simulated as you would expect it with snow to fly. But on the other hand, if you have, let's say, small particles in a, let's say, in a cup of water or in an aquarium, something like this, you might want to change these values and make them much smaller, but change the amplitude. Okay, let's go to the next setting here, the offset setting. I think the best way to demonstrate this is to change the offset speed. Let's do this quickly. So this actually is the speed at which the offset moves through the space, and this is again very easy to see with the debugging options. As you can see here, every line here represents a vector, and if you increase or decrease the speed here, the turbulence field will move with a different speed. It's pretty straightforward. You can also set this back to 0 and input some own values as you like. If you don't animate this here, if you don't set the offset speed, then the particle animation will always be the same. Lastly, we got the global force, which just does what you think it would do. It just adds a force into a random, not a random direction, but into the direction you enter here. Just a vector. So let's try it out. Set it to plus 200 on, roughly plus 200 on the x-axis, and as you can see, it just moves into the direction. You can use any other direction. Just basically is an additional feature for ease of use. The next thing you can do here to add more diversity to your effect is lock the offset, which will, if you need it to be equal every time it's being instantiated, you just check this box and the offset will be locked even if you move it around, and even if you're in world space coordinates. But if you want more diversity, you can randomize the offset here. So every time you start the game, these offset values here will be randomized, and yeah, you can define the range at which this is happening. Between, let's say, between 1000 and 1000 is the default. So let's keep this here, okay. But right now we don't really need this. Okay, now to the debug options. This is also very easy to use. You can change the colors to make it visible in your own scene. Just pick green in order to make it very bright to be visible, because only a few things are that green, just like a green screen, so you can see it. So the ray length here is a value that is used to adjust the size of the rays here drawn. This comes in handy if you have very high amplitude values or very low amplitude values. If you can't see those, you can adjust this value here to see the turbulence better. Now, as for the field size and the step size, this defines the space, the room in which it will be drawn. So on 0 on Y means it's just plain flat, and 5 volt units from the center in this direction and this direction, and 5 units in this direction and this direction from 0, 0, 0, which is the center of your particle system. If you define the step size, if you make it smaller, then there will be more particles drawn, but you should not do that. You should do this carefully, because if you draw too many vectors here, too many rays, then it might be very stuttery. You could get frame rate drops and even maybe freeze unity. But just be careful here. If you use higher values, then it might be possible to not see really what is going on here. So depending on the size of your level, you just have to try it out just a little bit to see what your turbulence looks like. You can always turn it on and off to see, for debugging purposes. Now the next thing you can do with Hayate is collision. This is very easy. It just emits particles when a collider that is attached to your particle system, just like this, hits a different object. Set it to 0, 0, and 1, 1. Let's say this collider would hit some object. It would emit additional X particles you can define here. Another feature is the transform particle. If you want to emit some transforms and set them to the position of the particle, you can adjust this here. So let's try this out. Create a new 3D object, cube, make it smaller, and of course these transform particles take a lot more performance than usual, so you might have to reduce the particle count a lot. Let's try with 100 particles. Go back to the transform particle options tab, drag and drop the cube in here, and these options allow you to define what happens after the particle death. So this is just being deleted, but you can also say it's being deleted after a delay. This is very handy if you use trail renderers, for example. Then you don't want them to be deleted immediately, or else they will just pop away. So you want to wait until they have completely retracted, disappeared, and then destroy the game object. You can also change the direction of your transform particle, but I think it's best to just show you what this does. Okay, let's remove the box collider again. Let's see. For this effect you will have to start the game actually, because otherwise it could spam a lot of unwanted transforms into your scene, and these are being cleaned up by Unity for convenience. So what you can see here, it's already started to emit some particles. Let's drag this side by side. I hate this color, so we change it to black. Create a new light, directional light, and let's move the camera closer. As you can see here, these particles move along and just overlap with the particle positions. They're being parented to the particle system and can be deleted by yourself or using Hayate, but I think the easiest way is just to let them be destroyed after the particle death. Okay, now change this again to delete, and as you can see here, now they just pop away. You could also add a script to your transform particle, to the cube, for example. Let's say make it smaller over lifetime. Unfortunately, it's not possible to read these values from the particle itself. That's because it's a stateless particle system, which means that only the start values will be entered in there and not the actual values. So this might be a problem, but you can just create your own scripts and make sure that everything is going fine here. Now let's see what this transform particle rotate is not being altered button does. As you can see here now, every transform particle now looks into flight direction. Let's say you want to have a bunch of planes flying around, or maybe fish swimming around in the water. Then you could just add a fish mesh with an animation and have them fly around. Not fly. Yeah, that fish, they're swimming, and have them swim around in your aquarium, and have them look into the correct direction, of course. Okay, let's move on to the next settings, the attractors. Attractors are basically points that attract or repel your particles. You can add and remove some of them here in the attractor tab, and let's do this. As you can see here, the attractor has been created. You can move it around and change the strength of the attraction. If you set it to a negative value, it will repel. If it's a positive value, it will attract. So let's just adjust the shuriken particle emitter a little bit to make this even easier to see. Okay, I'm going to set this to relative simulation and just put in some small values so the turbulence will not interfere with our attraction stuff going on here. If you move it around, you can already see what's going on here. Now what you might want to do is create some vortex effect, and to create this you will have to limit the velocity over lifetime. I just put in some values here, a small curve, and set the dampen value to 80%. If you turn this off, you can see that these particles are not getting slower and not being sucked in. Changing the attenuation might come in handy if you want some particles to be affected by the emitters and some particles are not being affected. So let's say your particles are not touching or not coming into the attenuation field of your attractor. They will not be affected at all by the attractor field. And if we move it closer again, you see they're getting slowly sucked in, and the closer they are, the stronger the attraction field is. You can always remove them or add more attractors. They will appear as different game objects, and you can change those values independently. Let's try to set it to a negative value. You can see all these particles are now flying away if they're inside the attenuation field, of course. Let's remove them and go to the next tab. So next up is the Mesh Target Options tab. which allows you to move your particles toward the position of a designated mesh. You can toggle between normal mesh and skinned mesh by pressing this button here, and I'll show you quickly how this works. Create a new sphere, and since the sphere is a normal mesh, just drag and drop it in here. It needs a mesh filter attached to the root of this to work properly, or else will prompt an error message. And as you can see already, it moves toward the position of your mesh of the vertices. You can change the speed and the simulation speed here. It's physical, which works just like attractors. By distance makes them faster the closer they get to the vertex, to their target destination position, and by time, which needs much higher values in order to reach the designated position. If you need more vertices, you can subdivide your mesh, but make sure that you save your mesh in the scene, because Unity can't save the new vertex position. So instantiating won't work with the subdivide options here. The next options are the special effect options. Just let me remove this quickly here. You can use those effects for UI effects. It will create some particles in a grid kind of way. So let's maybe deactivate the turbulence for a second and just see what this effect will look like. Let's set it to 0.1 in the Z dimension to have only a 2D surface here created. So this will create those particles in a grid kind of way and change the lifetime of these particles to make them disappear in the specific order. You can set the order here, the build order, using this drop down menu here, top button. Just press emit to preview your settings, and then you can see those particles disappear in a second. You can of course animate those values here. Let's animate the size of a lifetime. Start very small, become big, and then get smaller again. Emit. And you can of course create some cool effects with this. You can also have this create a cube if you like. There's some extra functionality you can use to create some cool effects. Let's try something else. Bottom left, top right, emit. In 3D space, of course, one axis is always the same, so the very end in Z direction will be the last particle visible. Another new powerful tool that comes with Hayate are animation curves. You can use these curves in almost all these values here, amplitude, frequency, offset, and some other tabs here, to create some very unique looking effects. Just hit the button next to the label and you can enable your turbulence curves. Let's see what the effect looks like. So this starts off with a very small amplitude value here with almost 0. What I have to mention is this time here on the x-axis represents the particle emitter lifetime, so this will be about 5 seconds. So you might want to move the very right keyframe to 5 seconds and increase the amplitude a little bit to make it faster. Maybe we make it the other way around to see that it gets slower over lifetime. So 5, 5. Scroll out, move the keyframe, and set it to this position here. Make sure that the amplitude value is never 0, otherwise it will prompt some messages here, frequency, amplitude, and no, that's it. Amplitude and frequency only need values bigger than 0, so you should make sure that this is always set to just a very small value, maybe 0.0001 or something like this. If you don't want to enter these curves here, you can create a new preset, and you have it here in the preset window. You should have it here. I don't know why it's not working. Okay, then I guess this is some kind of a Unity feature, so we have to put it in by hand again. 5, 5 twice 0.1, and let's see what this looks like. Maybe we increase the amount of particles a little bit and follow these particles. You can see they're getting slower, and since these particles here are being emitted per second and the time here is looping, the effect will loop as well. So let's just remove this box here and see what this does. It will emit those particles at a very fast amplitude value and then slow down. And you can do this with all the other values here to create really cool effects. You can even go inside to some other values here, animate the speed of your mesh emitter, for example, of your mesh target, excuse me, and then you don't need to animate the velocity over lifetime. Let's turn this off again to see what this now looks like. Maybe set the frequency to 0.5. Emit again, and see those particles become slower. I hope you like this introduction. If you encounter any problems or have suggestions, please don't hesitate to contact me under support@maxproud.com.